Anytime we run into an electrical hazard, it can be very life-threatening to our responders. With all the other things we're worried about, with fire and traffic and everything else, electricity is just another one of those things that we have to deal with. It's important for us to determine where and how to shut off the electricity. Crawling around, our boots have an electrical hazard rating on them, but they're not tested. In fact, if they've had a hole in them, and every firefighter's had a pair of boots that's had a hole in them, they're no good anymore for that. And we aren't walking on our feet. In most cases in a house fire, we're crawling. So we're crawling in wet gear in a wet environment, and you can crawl right across to an outlet or a cord that's laying on the ground that's energized, and then find yourself in a lot of trouble. The problem with electricity is it's silent. It's a silent killer. You don't know it's there unless you've confirmed that it's not. It's always considered to be there. Everything is considered energized. Everything on a pole, any wire coming down off the pole could be energized if it's in contact with another wire. So in a house, unless you've been told and confirmed that it's de-energized, consider everything energized in that house.
The usable voltage of the consumer, that 120 volt, is more than sufficient to kill you. It's 50 volts to push a quarter of an amp through the human body, and that's enough to kill you.
People always think about how many volts are there, and it's really not the voltage that hurts you, it's the current that hurts you. And it takes less than 1 amp to kill you. A standard outlet in a house, a normal breaker for a standard outlet would be 15 amps minimum. It could be up to 20 amps. So there's plenty of current available in a standard outlet to kill you. So we want to avoid any contact with electricity whatsoever. Everybody wants to get in and get going. Fire can grow very rapidly. So taking the time to secure the utilities can be a challenge for some departments because it takes another person to do that. And then if you get there and you can't shut things off outside, it's very tempting to try and do other things, and you really have to wait for the utility at that point. And that can be a very difficult thing to do with emergency responders. You can never train enough for an occupation that you can die in. So even as a volunteer, the risk is still there. A fire is a fire. It doesn't care whether you're being paid to be there or whether you volunteered to be there. So it's important for both volunteers and career fire departments to focus on this thing. And it doesn't happen very often. That's the thing. It isn't a huge risk factor because we don't see it happen so much, but when it does, it's a tragedy. So we want to make sure we're prepared for that, realizing that the electricity is in every house. It's going to be in every incident that we respond to, at least as in a structure. So we need to make sure that we have a plan to mitigate that.
Education on how to deal with a power line situation, a utility situation will greatly decrease the likelihood of a fatality to a first responder due to the situation.
In your firefighter training, you should have been trained to properly disconnect utilities, including water, gas, and electricity. Electricity should always be done with a switch or a disconnect point. Never do the meter. The meter is not a switch, it is not a disconnect point. Don't take your cutters, go up on a pole and try to cut wires loose either. Wait for the utilities to do so. In disconnecting the utilities, certainly wear your full PPE. It's not intentionally designed for arc flash protection, although it is NFPA rated for fire and heat protection as well. So it will offer quite a bit of protection. Make sure your face shield's down and wear safety glasses if you can. Certainly you could wear your SCBA and do that disconnect as well. Call the power company first. When you're heading to a structure fire and you know you're going to be needing to do a disconnect, call the utility, get them on the way. They don't have the luxury of driving with lights and siren, so it takes a little longer for them to get there. It can be very frustrating waiting for them, but they do not have the luxury of emergency response that we do. It takes less than 1/10 of an amp to put somebody into cardiac arrest. Your household current itself is rated at 15 amps on a normal breaker, so we're well over the limit that we need. You don't want to mess with it. If you're outside and you've shut off a main disconnect and their automatic standby generator is downstream of that main disconnect, it will automatically turn back on and re-energize the house. Smart homes, it is designed to keep itself alive. It's designed to keep itself energized. So when you shut the power off, even if the utility shuts the power off to it, it can turn itself back on. So you need to make sure that you're aware of where those are. Most of them will either run on gasoline or propane or some type of natural gas. So there usually is a place to disconnect by that generator as well. We've got UPSs for computers that can potentially backfeed if wired improperly. We're putting battery packs inside of homes now. That is inside the garage. It's inside the facility. Can create some fire hazards for us. But again, the power can come back on and you didn't expect it to. Installed properly, there should be a sign that says there is an alternate energy source there. Examples would be a generator, solar panels, battery backups, things like that, if it was done properly. The odds of it being done properly on small standby generators that you can buy at local box stores are very limited. I've said this before, the meter is not a switch, it is not a disconnect point. Pulling that meter, if that meter it isn't capable of breaking the load at that point, that meter could blow up in your face. It could actually cause more problems and more damage. Beyond that, though, not all the meters have all the current flow going through them. Some of them, there is an actual instrument somewhere else that is sensing the current flow and it sends it to that meter. So the act of removing that meter does absolutely nothing to disconnect the service at all. And if you don't know that, if you aren't trained to that, you shouldn't be doing that either. The act of opening that meter up, on the backside of some of these instruments, you can have incredibly high voltage generated, which could actually injure people that are exposed to them. So it's just not good policy to pull the meter ever. So wait for the utility to properly disconnect. A common call that we get is a car versus pole. And a lot of times, the power line isn't down, but you don't know that until you get up on the scene. So as you approach that scene, you want to make sure that you're looking at all of the hazards that are on that scene, other vehicles, traffic, everything else that's there, including the power line. Once that pole is damaged, we can have all sorts of potential for wires to fall, or there could already be wires down on the vehicle. And again, they don't make any noise. If they're not sparking, you may not visibly see, but the vehicle could still be energized. So the first thing you want to do is make sure that you secure the scene, keep anybody from the public from approaching that vehicle, and include your crew. Your crew shouldn't approach that vehicle as well. If you can stay in your vehicle, you're much safer staying in your vehicle. And if you make contact with the power line because you didn't see it, back up and just try to get away from it with your vehicle itself. If there is people in the vehicle and the vehicle is energized, we want them to stay there. We don't want anybody to touch that vehicle at all. Now, that's going to be very difficult. If that person is unconscious, you're going to want to go help them, but you've got to stay back. You've got to make sure that you don't become a victim. If the vehicle is on fire, well, that creates another challenge for us. We want to try and control that fire as best we can. The best way to control that fire is to have the utility shut off. Any electrical fire, if you can just shut the power off first. If the victim is capable and has to exit that vehicle, then we would want them to try and jump free of the vehicle, not touch the vehicle and the ground at the same time. You think about if you drop a rock in the water, how it sends those ripples out from there. Electricity is doing very similar to that. When the electricity energizes the car, you have a ripple effect in the earth. We call it step potential or touch potential. Touch potential is if you're touching the car and the ground at the same time, you could become shocked. If you're on the ground, well, there's current flow through that earth, so there's a difference of potential from one step to the other. So what we want people to do is either hop or shuffle. Now, anybody that's been an emergency responder for a while, telling somebody to hop or shuffle after they've been involved in a car accident, this is absolutely a last resort. Stay clear. I always tell people with grass fires, it grows back and it looks prettier when it comes back anyway. So, there's no sense in risking your life to try to extinguish a grass fire. Maintain distance from the power line, not just the 50 feet that we've talked about consistently. Think about the spans. Once the tension is broken on that wire, it can cause uneven tension on the next structure back. If it's involved with fire, it can be even weaker and that pole could fail and fall over on your people as well. So maintain clearance, call the utility and let them know that. As soon as you determine you have an electrical hazard that you're dealing with, you want to make sure you notify the utilities as soon as possible. And there may be a variety of utilities in the area. You might have a rural electric cooperative, private utility, a transmission cooperative, a transmission company, a municipal utility. So there's a lot of utilities in the area. So it's important that you pre-plan your area to understand what those utilities are and what their emergency contacts are. Once you make that phone call, you wait for their direction at that point. You need to stop, make sure you stay back until somebody from that utility tells you that it's secure.
Being a first responder and coming on the scene with large equipment, boom sprayers, cranes, excavators, stuff like that, do not approach the equipment, until notified by the utility provider that the power is off and it's safe to do so. When the boom is in the power lines, whether it be a sprayer or excavator, just because that equipment is in the power line and touching the ground does not mean the power line is off. If you would go up to that piece of equipment, it's likely that you're gonna create a path to ground and you'll be electrocuted. If the operator's in there and he's fine, tell him to remain inside of the equipment until notified that he can get out when the power company shows up. If he's panicking and feels like he needs to get out, or if there's a fire, instruct them to hop off the equipment and hop away through that step potential gradient of a minimum of 50 feet, if not further. Do not make the scene worse by approaching to help and becoming a victim of electrical contact yourself. Some other situations that first responders might come across the scene of dealing with power lines and utilities upon a rescue or a fire would be storms, windstorms, ice storms, thunderstorms. Anytime that a pole can fall over, get hit by lightning, and the power lines become disconnected from the pole. Floods, quite often, where the power lines cross rivers and creeks. When they flood, the ice flows or other debris will knock the power line poles over, or the underground electric utility boxes, and that can cause a fire. Airplanes, crop dusters. We've had several of those where they'll go through a power line and knock the power line down. All those situations where the power lines fall down, energized like that, it can create a fire. And that's when fire trucks are going to get called out and first responders. And upon arriving to the scene, the best thing they can do is keep back a safe distance and keep the public out of the way and keep themselves out of the way until utility provider shows up and makes the situation safe, turns off the power lines, and can start replacing poles and repairing at that time. Underground utilities, even though it's just a green box in someone's yard, it is a transformer just like you see up on a power line pole. It's got high voltage coming in and it's transforming that power into usable voltage for the member. It's a pad mount transformer in a box full of mineral oil. If it was to be compromised by hit by a car or a tree falling on it, it's a high likelihood that the transformer is going to stay energized. Upon touching that transformer, you are touching an energized piece of equipment, and that can be fatal. We're starting to see more and more underground utilities come out all the time. A lot of times they're in the road right-of-ways, which makes them prone to being hit by cars. If first responders ever get called that there's a broken box, a tipped over transformer, a transformer with the lid open that has come unlocked, and they get called, they should go out there, make sure the scene's safe, keep the public away, and call the utility. They really don't need to do anything with it until the utility comes up. If the transformer is on fire, they should leave it alone. Let the fire do its thing. Don't put water on it. Just let it burn itself out until the utility comes out. The main thing is, I can stress, is call the utility company as quickly as possible. The sooner they're notified, the sooner they can get to the shop and head out to the area. Quite often when a car hits a transformer, it rolls the transformer over. And upon doing that, the elbows get pulled off and can come in contact with the vehicle, and the vehicle can be energized. Most likely won't be arcing and sparking. And there's no way of knowing whether that car is energized or not. So call the utility, keep the person calm, tell them to remain in the vehicle until we show up, and then they can safely get out. If the vehicle becomes on fire, have them jump away from the vehicle and hop through the step potential gradient until they're a minimum of 50 feet away. When involved with an underground transformer, underground utility, treat it as an overhead structure and power line, even though you cannot see the lines and you cannot see the terminations inside the transformer. The same voltages of dealing with high voltage are there.
You know, one of the very rapidly growing part of our electrical distribution systems is solar. A lot of industries are installing large solar panel systems that are out, standalone systems that generate electricity, and they put it straight into the grid. Those would fall into a category of don't enter until you have a utility person with you. Again, you need to treat everything as energized. The brackets, everything needs to be considered energized until a utility employee gets there to accompany you. Once you start putting them on the roofs, though, we have added weight. It wasn't designed for that originally. Now, under fire load, if we have fire conditions underneath that, you could have an earlier collapse in that area. The other side, they could fail and slide off the roof. So you need to be aware of that. If your people are located underneath that, you have an increased hazard of something sliding off the roof and hitting them. If you're going to go up and fight a fire or ventilate, really that takes that option out. You're not going to cut through the panel or remove the panel to get to the roof. You know, roof operations can be very dangerous anyway. Now we've added load to that roof and we've added another hazard. We can't touch the brackets. We don't want to touch them while we're up there. So it really takes that option away from you from ventilating at that location. We also have requirements on disconnects for those. So when you go to the panel to do a disconnect, there's going to be some red signs there that are going to tell you that there's an alternative energy source there. Just by the way solar panels are built, they are always generating electricity when light is hitting them. You know, and it's not just daylight. If your scene lighting is hitting them, they're generating electricity. If your moonlight's hitting them, they're generating a small amount of electricity. So you can never really say they're truly off. You can shred them and the photocells themselves will still generate electricity. So even after a tornado or a collapse from a fire, these things can be laying inside of the wreckage of the house and still be energized. So make sure nobody's touching any part of them, any metal on them, nothing. Do not touch them. A lot of people that have the solar may have a battery backup as well. So being aware that the battery's inside that house, if there's an inverter, they can be regenerating power back inside that house to keep the house on during outages. So, all these things are concerns for us. Again, it only takes 1 amp to kill you. So these things can do it. Responding to a pole fire, it's not uncommon for us to get called to something like that. So when you respond to a pole fire, obviously you know that there's probably an energized power line involved. So you're already alert to that problem. Notify the utilities in that area. If you don't know which utility is, go ahead and call them all. They're okay with that. A pole fire could be burned from the inside and have very little damage to it. When you get there, nothing's happening. Still stand by, give your area of protection, secure the scene until the utility gets there to go through that. Sometimes when you get there, the pole's actively burning. Don't spray water on it until the utility gets there. Spraying water on it can actually make it worse. Wood's a conductor and people don't think about that. Wet wood is a much better conductor, so by adding water to it, you make things worse. If a power line is down, wait for the utility to do anything before you begin fighting that fire. Now, if that fire is in the wind and it's going away from it, as long as you maintain clearance from that power line, at least 50 feet, or add the distance of spans to that, you can go ahead and fight that fire as it is further away from that line and protect other exposures. But never position yourself underneath the power line, so if the line was to fall, it's not going to land on your vehicle as well. Getting called to a grass fire could actually be a down power line that started that fire. And the difficult thing with this is power lines can be very difficult to see. Doing a scene size up as a fire officer when you get there is making sure that you look for all of these hazards. Try to determine what caused that fire. It may not have been just a cigarette flipped out the window. It could have been a power line laying there. So look up. If there is a line, look to see that line is still up in the air. If there's 2 wires hitting one pole, there should be 2 wires hitting the next pole. Electric vehicles, when they first came out, it was a novelty and it was new, and a lot of people did a lot of training on it, and it caused a lot of confusion. Now it's just called a vehicle. We have hybrids, we have electric, and you can't really tell whether it's an electric vehicle by walking up to it. A few of the things that are kind of scary, with a vehicle accident, nobody thinks to put their car in park. Nobody thinks to set the parking brake. They just are in the vehicle when we approach. An internal combustion engine vehicle, when you approach it, you can hear if it's running. You don't know if an electric vehicle is running or not. It can be in drive. When you approach it, if the person pushes on the accelerator, it can move. They're going to drag you and every responder with them. Or if anybody's in front of the vehicle, they're going to drag them with it. So chalking the wheels, making sure that we've limited horizontal motion of that vehicle is really critical to begin with. And then make sure that we secure that, make sure it's in park. If we remove the key fob from inside of the vehicle, that should shut it down. But if a vehicle's involved with an accident, it's re-engineered. All bets are off. There is a disconnect point on those. There are some apps that we can go to that will show us where those are. But it's just a quick Google search. If you have access to the internet on our phones, it is not uncommon to look for those things. Putting a car fire out that has batteries involved will take an incredible amount of water. One of the operator's manuals from a manufacturer said copious amounts. Once you've extinguished that, it still can hold the charge. These car fires from battery-operated vehicles may continue to reignite even months after that fire. Anytime you're doing any vehicle extrication, we need to peel and peek, which means you want to pull the trim back, you want to pull the carpet back and look underneath there. There could be supplemental restraints, and that's where we learn to do the peel and peek. But the other side of this is if you see a wire loom, particularly a large wire loom, don't cut it. Right? Stay away from any large wire looms. Some of the vehicles may have them inside of the vehicle. Earlier ones did. Newer ones have them externally on the vehicle as well. Again, if you see a large wire loom, don't cut it. Pay attention to where you're cutting. There are a mountain of resources out there for training for electric vehicles. My biggest thing is contact your local dealerships. Those are the vehicles you're going to be dealing with in your area more than any of the others. So contact your local dealerships and set something up through them. You can contact your state fire marshal's office and ask if they recommend any trainers in your area that they've had good luck with as well.